Guys, today we're talking about another one of our conic sections, and that's an ellipse. So an ellipse is basically an oval, and this is the definition of an ellipse. We're talking about the set of all points P in a plane such that the sum of the distances from P to two fixed points, F1 and F2, called the foci or non-plurals focus, is constant. So if you look at this little red line is technically the same length the entire time. And I think it's a little easier to see on this next one because the string isn't changing length. Okay, the string is the same length the whole time. We've just put two pins down. Those are our foci. Each one is a focus. And then we're just drawing that oval from it. So an ellipse, remember, is when we cut the cone and we cut it at an angle that doesn't go through the base. And so that's kind of what we're looking at today. So there is another set of equations that go with ellipses, and they look a little bit scary at first, but don't worry too much. Remember, this is on the inside of your foldable. It's going to be on the, hold on, I can't find my paper. It's on the white section, okay? So there's two ways that an ellipse can be oriented. It can either be horizontally, so it's fatter along the x-axis, or it can be vertical, which means that it's taller. So this is a horizontal one. This is the equation. Now, one of the things that you notice about on both of these is that they both equal to 1. So make sure when you're thinking about standard form, with the circles, we needed it to equal to something because that was our radius. Now we want them to equal to 1. So looking at these two, they look very, very similar. Now there's a couple of things to note in here. First of all, that this one is just like the circle. We still have that center at H, K. And it's still the same on the vertical one. They've just flip-flopped which one is X and, where is X and where is Y. Okay, so it's still the X coordinates with the X, the Y coordinates with the Y. So that's the center, HK. We have something called a major axis and a minor axis. So the major axis is just the big axis. Okay, so in a horizontal one, that'll be my horizontal one, my horizontal axis. And this one is length A. Okay, it's whatever is underneath. So my x radius, there's two technical radii here. My x radius is just length A. So the whole length of that entire axis is just 2A. Okay, whereas the minor axis is the little axis. Well, I guess I should use a different color. It's the little axis. And it's going to be length B. So if I had the whole thing, that's going to be length 2B. And again, that's the radius that's underneath the Y. My video's on YouTube, guys. And the next thing that you need to know is those foci. The foci on a horizontal one is going to be along the horizontal axis. It's going to be like right here. And that length is going to be C units from the center. So if I was to go look at my vertical, almost everything is the same. Okay, but when I'm looking at it, my little axis is going to be this guy. My big axis is going to be up and down, which then means that my foci are going to fall on my major axis. So that's the hardest part. The foci are on the major axis. The last thing you need to know is that A squared is always the biggest denominator. So A has to be bigger than B, and that's going to be bigger than 0. Otherwise, you don't have an ellipse. So A squared is always the biggest number. And then in order for me to find the focal length, or the length from the center to a focus, we're going to use this. This looks like a crazy, messed up Pythagorean theorem. C squared equals A squared minus B squared. And I could show you why this is true. You can ask me if you really want, but if you just take it, I know what I'm talking about, and I do for this part. C squared equals A squared minus B squared. So let's do an example. I think these become a lot more straightforward when you see an example. So first of all, we're given an equation, and it's not in standard form. It's not in that form that I saw listed on my foldable. So what I'm going to do here is, in order to get it in standard form, I'm going to move any constants over. So this 81, going to move to the other side. And then if you look at that standard form equation, I can't talk and write at the same time. Okay, if you look at that standard form equation, you're going to notice that the right side equals to 1. So I'm going to try to get this side, this right side, to equal to 1. The easiest way to do that is to divide whatever this number is, because 81 divided by 81 is going to give you 1. So divide this number by itself. Now if I divide that by 81, I've got to divide every piece by 81 as well. So now when I look, I can try to simplify down. This guy's not going to simplify at all. It's x minus 2 squared over 81. but 9 can go into 81. Be careful here, when you divide it, it stays in the denominator. Stays where it's bigger, equals 1. So now I'm in standard form. Now I can do something with this, and I can find all those pieces that they're looking for. They want to know my foci, and they want me to graph it. Okay, so the first thing that I'm going to go ahead and do is I'm going to graph, because I'm a visual person and I want to see the picture of this interesting ellipse. Wow, that was a terrible, terrible line. Okay, the first thing that I need to do before I can graph anything is I need to know where my center is. So the center of this guy is, remember, the x coordinates with the x, the y coordinates with the y. And so my 2 and my 2, -4 for my center. So 1, 2, 1, 2, 3, 4. Okay, the next thing that I'm going to decide is this parabola, why do I keep calling it parabola? Is this ellipse, is it going to be a horizontal? Is it going to be fat, or is it going to be vertical? Is it going to be tall? And the way I do that is I find my A and my B. Now remember, your A is always your bigger one. So your A squared is 81 here, because 81 is bigger than 9. So the square root of that would get me 9. And then B would be the square root of 9, or 3. So you notice now that the bigger number is under x, which makes this a horizontal guy, okay, a horizontal ellipse. So if your bigger number is under x, that means that you're going to have a fat guy. So I'm going to go ahead and count this out. This is kind of like the radius of my ellipse for the x coordinate. Oh man, I'm going to have to count 9 again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that point would be over here at, that was 2, so 11, -4. Okay, and then I'm going to go the other way too. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that would be my radius of that direction. Now I also have to go up and down. So for this guy, I'm only going to go 3. I'm going to go the smaller direction in my y. So I'm going to go 1, 2, 3. And so that one would be at 2, -1. I'm going to go 1, 2, 3. And then I'm going to make my graph. Oh, wow. Well, again, not judging you on your ovaliness of your ellipses. Okay, so again, the reason I knew that this was going to be horizontal was because my bigger number was underneath my x. Or when I graphed it, I can see that it looks fat instead of tall. So the last thing I need to do is find my foci. I know my foci are going to be along my major axis, which is going to be this one, my horizontal axis, but I don't know the distance. So in order to find that, I'm going to use my messed up Pythagorean theorem, which is c squared equals a squared minus b squared. Now you know why a squared is the biggest, so that way I don't have any issues with negatives. So I find that c squared is equal to the square root of 72, which is not pretty. I could simplify that down into a little bit nicer, but I think we can leave that alone. You can always get a decimal approximation if you need it. So the biggest thing when I'm trying to find the foci is to identify where your center is, and then remember that it's along the major axis. So when I find my foci, they're going to be like over here and over here. So I'm going to take my x coordinate for this case. It'd be different if it was vertical. And then I'm going to add or subtract that focal distance, that c value. Ugh. And then finally, it's going to be along the same y coordinate. So it's going to be at -4. Okay, so again, you can just write it like that, especially if it's not a pretty number. I don't want you to have to add or subtract crazy decimal things. Okay, so again, think about what's your horizontal major axis and what your focal length is. Okay, let's do another example problem. It says write the equation of an ellipse with a major axis of 8 and foci at those 2 places. Now, when I'm doing these, I tend to look at a picture just to kind of get an idea of what I'm looking at here. So I know that I have foci, well, that should probably say -2. They have foci in the same spot. Okay, so we have foci at 0, 2, and 0, -2. Now remember, your foci are always along your major axis, which means that this one must have a vertical major axis since my foci are straight up and down right here. So if I know then that the major axis is length 8, then I know that half of that would be 4, and then half of that would also be 4. So I have something that kind of looks like this. Well, hopefully a little better than that. So I know too, if then this is length 8, that my A value, my bigger value, should be half of that, or 4, to go up 4 and then down 4. Okay, so my A is 4 in this case. It's vertical, so that value is going to go under the Y. Now the next thing that I know about this is they've told me my focal length. They've told me that C is equal to the center to the focus. Now, how do I know that's the center? Well, straight in the middle of those two things will be 0, 0. So we're kind of lucky here. We have a nice one that's centered at 0, 0. So I'm going to go ahead and use the formula, the C squared equals A squared minus B squared, to solve and find B. Okay, so this one, C squared would be 2 squared is 4. I know A squared is 4, so 16 minus B squared, and now I'm just solving this out. So I'd subtract 12 or 16 from both sides and get negative 12. This is okay because I can divide both sides by negative 1, and I get that 12 equals B squared. Before you take the square root, remember that your equation has A squared and B squared in it. I don't really want to know what the square root of this is. Just leave it as B squared, because now when I plug this into my formula, remember I'm going to have x squared over something plus y squared over something, because I'm with the center at 0, 0. Okay, if you need to make a note, my center is at 0, 0 nicely. And that's always going to equal 1. Okay, so my major axis here is 4, and that's going to go underneath my y because it's tall and not fat. So 4 squared is 16. My b then is going to go underneath my x, and that's my equation. Okay, and if you flip-flop where the things are, that's fine. If you said y squared over 16 plus x squared over 12, that's still correct. Okay, I have one last example, and that's using a picture in order to find my equation. And this one, again, it's kind of the same thing that we did with the circle. You're going to go ahead and try to find the center first. That's always my first goal. So when I look at my center here, again, it's going to be where these two lines cross. They're not going to cross at perfect bisectors, but we're going to look here. Now, I know that it's going to share the same x, and it's going to have the same y. So the same x is the top or bottom point, and the same y is those side points. So my center for this one is at -3, -1.5. And if you can't figure that out with just numbers, my goodness, there's so many emails. Just go ahead and look at it and eyeball it and kind of see, yeah, that's got to be where it is. Okay, the next, so when I look at this, I'm going to write my center, my equation. I'm going to start my equation with my center. So I have x minus a -3 squared over something, I don't know yet, plus y minus a -1.5 squared over something, I don't know yet, and that equals to 1. Okay, when I look at this, all I have to do is now count out my horizontal and vertical radius. Okay, I know it's not technically the word for it, but it kind of is like the radius. So looking here, and for horizontally, I came from -3 and went to -1, which means that I traveled a distance of 2, which would then make underneath my x be 2 squared. Okay, if I look over here for my y's, I went from -1.5 up until 2, which is 3.5. So I could leave that as 3.5 squared. And this equation is perfect. And again, if you look at this, I have a vertical major axis because it's tall. And with that, I can see that my bigger number is going to be underneath y. So that kind of gives me an idea when I'm writing my equation. Wow, I just totally messed up that box. Okay, that's all I've got for you. We're going to practice some more with ellipses tomorrow. And I hope you have a great day.